In a right triangle, the tangent of one of the two acute angles is root 3 over 3. What is the tangent of the other acute angle? The biggest challenge with this problem is simply to draw the triangle, and so let's start with that. We'll call this angle theta, and then the simplest choice is to make the opposite side root 3 and the adjacent side 3. And then let's call this other acute angle alpha, which makes tangent of alpha 3 over root 3. Now, at the risk of overcomplicating this, any scalar multiple of this triangle would have been fine, but the natural choice is to select k equals 1. Triangle ABC is similar to triangle DEF, where angle A corresponds to angle D. What is the value of cosine of f? Cosine of f must be equal to EF over DF, and by definition of similar triangles, that ratio must be the same as the ratio of BC over AC, because those are the corresponding sides. That's 24 over 30, which simplifies to 4/5. If sine of x is equal to a, which of the following must be true for all values of x? If you remember your cofunction identities, then there's no work to do here. The answer is C. In a right triangle, one angle measures x degrees where sine of x is 4/5. What is cosine of 90 minus x? Now suppose that you don't remember the cofunction identities. The test makers like these problems because you can figure them out on the fly without remembering the identities. The way to get around that is to draw the triangle. And so let's try that once. We see that we have this 3, 4, 5 triangle with x as one of the acute angles, and that makes 90 minus x the other acute angle. Cosine of 90 minus x in this case is 4/5. Now, obviously, we could have gotten there much quicker by recognizing the cofunction identity. The angles shown above are acute, and sine of A is equal to cos B. If A is equal to 4k minus 22 and B is equal to 6k minus 13, what is the value of k? If you don't recognize the cofunction identity in play here, then you will have a rough time with this one. So let's start with what we know. Sine of A is equal to cos B, and we also have that sine of A is equal to cosine of 90 minus A. So the critical insight here is that B must be equal to 90 minus A. Once we have that, then a straightforward substitution ensues. We're left with one equation and one unknown, and that comes out to k is equal to 12.5. In the triangle RST above, point W lies on RT. What is the value of cosine of angle RSW minus the sine of angle WST? We'll start by giving ourselves a W, and then if you miss that the cofunction identities are helpful here, good luck to you. But there are two big clues that we need them. First, cosine and sine appear in the same problem, and then second, angles RSW and WST sum to 90 degrees, so let's proceed. Sine of angle WST is equal to cosine of 90 minus angle WST, and 90 minus angle WST is angle RSW, so we have that cosine of angle RSW minus itself is 0. Right triangle ABC is shown. What is the value of tangent of A? Most people will use trig to solve for sides AC and CB, but there are two issues with that approach. The first is that it's slow, and the second is that the calculator will return a decimal rather than a radical, which adds even more time because you may not recognize the correct answer without converting the answers to decimals. The preferred approach is to use the special triangle. AC must be 27, so CB is 27 root 3. That makes tangent of A 27 root 3 over 27, which is root 3. If you too would like to possess the power of special triangles, check out my video on that here.